Alrighty. So I'm going to talk about secure messaging today. This is going to be a very high-level overview of how Ethereum fits into secure messaging, because messaging is a very broad field. There's lots of different types of messages. So in my mind, like Reddit is a type of messaging, but text messaging is also another type of messaging. So there's a lot of different things to take into account with messaging, and each type really has different kind of things that you're wanting from it. So it's not going to be really a one-size-fits-all solution. And so I'm not really going to show you any solutions. I'm just going to show you maybe some like intuition about how you go about solving different types of messaging. All right, so I'm just going to go over just some different things you want to think about when you're determining what kind of messaging application you're writing, the role that Ethereum would play in these different spaces, and then I'm going to kind of break it down into two different roles and go into detail on both of those. Alrighty, so first thing with messaging, a lot of things. What kinds of messages are you going to want? Is this just a text message application? Are you building the next WhatsApp? Are you building the next Skype or Mumble? Or what exactly is the purpose of the messaging? Are you trying to integrate different types of media together? And each of these different types have different requirements to them. So a text message, that can be something that is very easily stored on like a server. It doesn't take very much bandwidth to send. But then you have streaming HD video that's it's gonna be a little trickier to actually do that if you want to do it in real time. Who can read your messages? Are you just sending a message to a friend and you're wanting that to be private between you, end-to-end encrypted? Are you broadcasting with a group of friends, Google Hangout style? Or are you just broadcasting to the world? You want to use something that's decentralized. So think of like Reddit, but maybe more decentralized. So how are the messages stored and transported? So are you talking directly to someone in real time, or are you putting your message kind of on a server somewhere, or are you putting it out somewhere for anyone at any time to come back and later see? So if someone posts something on Reddit, for example, I can come back maybe a day later, and it's going to still be there. I don't have to be on the website while that person is posting in order for me to get that message. So there's determining which of those two you need, you will end up having different requirements for your project. And then how do you identify who, if you are actually limiting your messages to certain people, how do you identify who the person is? Well, luckily we have identity contracts, so that may be one solution towards that. So Ethereum's role, I'm just going to kind of go over two different roles that I see that Ethereum could play. The first role is the message storage. So you're using Ethereum in this case to store what the message is. You're storing the content of the message on the actual blockchain. And that has a whole host of benefits, and it's also has its own drawbacks. We'll kind of go into a little bit more of that a little later. And then another way of looking at what Ethereum could do is acting as a decentralized rendezvous point. So it's going to hold maybe the relationships between people, or the connections necessary to send messages. So maybe not actually storing the message itself, but maybe storing your friend list or your address book in the blockchain, and then using that, looking up that information and then being able to connect with your friends elsewhere. Then there's others. I'm sure you could reason about this a lot of different ways. This is just something that I put together. So if you've got any other ideas, feel free to let me know. I'm very interested in all this space. Okay, so using Ethereum as a message store. I'm just going to go over some of the benefits and then some things to consider if you are going to be using Ethereum to store your messages. So one of the benefits is it's very easy to broadcast the messages on the blockchain, so you don't have to worry about how you're going to transport the message or anything like that, maybe the content of the message or how the message structure. But beyond that, if anyone has the blockchain, they can read your message just unencrypted. It's also asynchronous, so someone can later go and look at your message, even if they're not online at the time. This is really handy, just because both parties do not need to be online.
Isn't this the way BitMessage works, this one?
Yeah, it's kind of the way BitMessage works. I think BitMessage cycles the messages around through a network, whereas I guess Ethereum would have, each node would have the full content of the entire blockchain.
Okay.
So the design of BitMessage is designed that way to resist traffic analysis.
Okay.
So they don't want you to be able, so with your design, the global passive attacker could be sitting there watching messages be read out from the network and go into the network and determine who's communicating with you.
Oh. Okay, good to know. I guess that's another consideration that I didn't have listed there on your messaging. It's, what is secure? Are you wanting it to be private or are you wanting it to be anonymous? And there's way different requirements for both of those. Some considerations, kind of like a public message board versus a private mailbox. How are you protecting your data on blockchain? It's a little bit harder because everyone has access to it. So if you're wanting it to be protected, you're going to have to encrypt it somehow with some key. And if you're wanting to stop people from overwriting your message or from tampering with it, then there's going to have to be rules in the contract or in a contract somewhere that is going to limit who can edit that section of the storage. So one way of doing that would be a whitelist of all of the addresses that could access that region, or even just maybe one address to access that region. And then other rules, so is it just going to be like a flat message board, or is it going to be voting? Are you going to categorize the messages into different subgroups? Are you going to have people replying? And all of these different rules that you add on are going to be rules that you're going to have to add into a contract. Because if you're having the message on the blockchain, all of the logic beyond that is going to be in your contract. So those are just things that are going to have to be built in. And remember, the more logic there is, the more you're going to be paying to run your contract. I want to go over an example or two here. So I actually made a really naive Ether mail or email through Ether. Does not have all the features of email at all, but probably you could add that on. So how you're going to want to use an email message or an email contract. I'm just going to go through the contract and then skip back up here. So the first line, basically, if you are, the only thing you're allowed to do if you are the content creator or the contract creator, we're assuming this is your mailbox contract. The only thing you're allowed to do is suicide it, get rid of it if you are done with it, I guess. Otherwise, it's going to be someone else who's sending you a message, ideally. And so you are just going to pull the index of, basically you're going to create a list of all of the messages that have ever been, this is going to be a list of all the messages that have ever been sent to you. So you're going to pull the next index of the next slot in the contract to store the message at. You're going to set that contract storage space to the the transaction data 0. So the first piece of data that's sent in that transaction is going to be the message itself. And then you're going to increment that index for the next person to store their message. So this is really basic, but basically it's just a little mailbox. Set put messages in there and it'll stack up. I put the suicide in there because I figure it's going to get really big, really fast. There's no way to delete any messages in here, so that's why it's really naive. But you can have app logic on top of this that will basically figure out, you tell it which contract is your mailbox, and it will go and retrieve those messages. Now you can add in other, you want it to be more secure. Maybe everyone who sends you a message encrypts that message with your public key before they store it. So in the transaction that they send to Ethereum, it will include just the encrypted message as the 0th data element.
Could you repeat what you just said? Because the +1 thing and what you just said is really neat.
Okay.
But I think, yeah, so repeat that. Yeah.
Okay, so we have to store the length of the list of messages in the contract so that the next person who puts a message in the contract will know where to put it. So basically it increments every time because a new message is added to the contract every time. So then we can use that number, that stored number, and add that. I started at 1,000 because, or that's just an arbitrary starting point, but you basically will add 1,000 plus 0 the first time, and so you're going to store the first message at 1,000, and then the next time it's going to be, your next index is going to be 1, so then you're going to store the next message at index 1001, and then you're going to increment it to 2, so then the next person will store their message at 1002, and so on and so on.
Thanks.
So the only thing you need as an application would be to look this information up and decrypt it if necessary. It might be good to have some sort of protocol or some sort of message format that is more structured than just dump stuff in and get stuff back out, like encrypted. And, yeah.
How would the suicide need to be implemented? I mean, I understand what suicide means, but I don't. Oh, well.
Okay, so yeah, the idea behind the suicide is if the suicide gets called, then the contract gets destroyed, and then all remaining balance gets sent back to.
I don't know what destroy means.
It gets removed from the blockchain.
So the way no one should ever execute this contract again because it's poisoned.
I think it's removed.
It's removed.
Yeah.
So what happens, the way you suicide this contract is if you created the contract, you send it a parameter of 1, and it basically refunds the balance of the contract to you, and the contract is wiped off the chain. Now if someone tries to send Ether to that non-existing contract address, they'll burn it. But it won't be in the list of contracts that are available. So unless they're silly, they won't do that.
Does that make sense?
The idea is that the contracts use up space, excuse me, so you want to have a mechanism to remove the contracts.
So contracts are not in the blockchain like I thought they were.
Well, there's actually separate data space. There's a separate data space. I mean, that's all. The blockchain is a little bit different from the data storage space is separate from the blockchain. Correct me if I'm wrong.
Yeah, it's all on the chain. I mean, the contracts are on the chain. They have an internal state. They have an internal state that goes away. It's just session based, and then they have a contract storage which is persistent. He's referencing that here. Once it's suicided, though, so the contract has an address of its own, as if it's a user of the wallet. But once it's suicided, I mean, the contract's off the chain.
Will the previous storage be available? Like, is there any way?
I think it's basically liberated, so the chain's.
Yeah.
One more question on that. Yeah, this is sort of the first time you do one of those. Is the storage pre-allocated on contract creation? Is that why we're indexing into it? Or is there any mechanism
They're all
It would be
zeroed out.
allocated storage.
It's all zero. It's not, when the contract, so the storage is in this format that basically allocates new memory as pieces are used. So when they're not used, they're just not there. And so when you try to reference them, it'll return 0.
Okay, so I guess my question is, why would you need a next index of storage if you've got like a list of free and a list of allocated storage?
Because
Is that what you're saying?
yeah, you need some logic in the contract itself to figure out what the next slot would be. So you can either go through line by line and go n messages down until you get to the n+1 message, or you can store whatever n is so that you don't have to go through every single message. Is this 0? If it's 0, then I can put something there. If the next one is 0, or so basically if there's 10 messages you have to go through, if you didn't store the index, you'd have to loop through to get to that 11, 0.
So the programming model is there's a single associative array that you have to put all your data in somehow.
Yeah.
And it's huge. Like if you wanted to use
Sparse,
it,
right?
it's huge. Yeah, it's sparse. It costs to put stuff on the chain, so you can't just waste it. But there's so much storage space there. It's 2 to the 256 of these storage slots, like contract storage angle bracket 1000. That holds 32 bytes, but there's 2 to the 256 of those available to you.
So the indices can be hashes.
Yeah, and then you have to pay for that with Ether as you execute the contract.
Right.
But you have more storage than you could ever want if you could afford it.
All right, so here's kind of a similar contract. This is just implementing a very simple message board that has different topics. And so you can post a message under a topic. So we're going to say that data 0 is going to be the topic, and data 1 is going to be the message. So you can see this, we've got the next index again, like last time. And this, what we're doing now is basically we are saying we're taking the SHA-3 of the topic so that we can more evenly spread out these different lists of messages. Otherwise, it would be a little trickier. Or using a hash of the topic allows you to get a more random distribution of the memory, so that you aren't going to have one list of messages for a topic overwrite part of another list of messages for a different topic. So what we're going to do is we're going to store the length of the message. We're going to store the length of each topic message list at the SHA-3, at the index of SHA-3 of the topic. That's this first line next index. And then we are going to add the next message to the next slot. So we're adding +1 right there, and then plus index, so that we're not overwriting the length of the topic list, the topic message list. Although because we're assuming that everything gets initialized as a 0. So on the very first time when the length is 0, you're going to have SHA-3 of the topic +1, which is exactly what that's the next slot after the length. So that's the reason behind that. And then the last line is just, we are incrementing the index again. So, do you have any questions about this one? The way it would work from like an application perspective is, you would say, I want to look up the messages for this topic. And then you would look up on this contract's storage. You would take the SHA, the SHA-3 of the topic, and then that storage slot would be the length, the number of messages that you need to look up. And so you basically be able to pull those n messages starting from index of SHA-3 of the topic. And that could be displayed any way that you like. This is very naive, doesn't have any permissions or any kind of spam control, deletion, or anything, but basic message board. All right, so we're going to go a completely different direction here now, and away from storing messages in the blockchain, and now look at using Ethereum as more of a storage of the different relationships that you're going to need to connect different people or to connect different entities to send messages between them. So the benefit of this approach is really flexible because it's not, transport is not the blockchain itself, so you can use really any kind of like secure transport that you would want to use. Maybe two peers are connected to a website, and they're connected via some like a WebSocket or something, and you use you have like a friend list, so you can tell the server I want to connect to this friend, and it will. You can just route those through a WebSocket. You can route them through HTTP requests. You can route them through WebRTC, basically, or whatever IP packets, or TCP, whatever IP. So it's not relegated to just the blockchain. Even the relationships that you add in the blockchain are not necessarily just so static. It's not just a friend list or people I want to know. You could basically add your identity to a list of similar demographics of people that you want to connect with. So maybe I want to connect with all the people who want to talk about dogs. So now I put myself in a list of peers that want to connect and talk about dogs, or what really, and people who are geographically close to me. I want to talk to them. And there's a real possibility of more real-time communication. So the other method, you're kind of limited by the 1-minute block updates. So if you want to send a message and then someone else reply, that's going to be 2 minutes. And then the next reply is going to be his 3rd minute on average. So it's not really real time. But having just who you want to talk to or where you want the message to go allows you to, that changes a lot. That changes a lot less often and doesn't necessarily need to take 1 minute at that point. So the considerations, again, so what kind of transport medium are you using? Are you connecting to the same website and using like WebSockets over the website and relaying messages through that? Are you using WebRTC, which we'll go over here in a second? Are you using BitMessage to actually send the messages? And that's really up to you for whatever kind of purpose you're using this messaging application for, or how you're actually wanting to communicate. And then, depending on what you use, you may or may not need both parties to be online. So, in the example of WebRTC, it's a browser-based person-to-person communication framework. It's person-to-person. You need both persons online in order to actually communicate, versus a BitMessage where I can just kind of post my message up and it'll float around the network until the other party gets online and you can then read the message. And then storing who versus how trade-offs. So really this rendezvous point could be broken out into a lot of different types of uses for uses for Ethereum with messaging. But you can kind of think of this as more storing the who you're wanting to talk to, or how you're wanting your message to get sent, or how you want it to be routed, or even really where you want it to get routed. So who is a lot less likely to change. Who you're wanting to talk to, maybe your friends, maybe. But people's identities really change less often. But you're still having to worry about how you're doing it. So then again, how is the message getting from point A to point B? And then how you may be able to perform some sort of secure handshake via the blockchain, but you're going to be limited again by the 1 minute block update time. So that would really hamper any efforts on that. I'm going to go to a quick interlude here and talk about WebRTC a little bit. If you have not heard about it, you should definitely look it up. Coming to a browser near you. So basically, it stands for Web Real-Time Communications. It's being built into every major browser as we speak. I think it's actually on by default now on Chrome and Firefox. So basically, the idea is you have person-to-person connections from browser to browser, or it doesn't have to be a browser, it can be a server to a browser. There's a C++ API you can use as well. And it does audio, video, and data connections. And you can tweak the audio, tweak the video, high def, small, low resolution, this codec, that codec. I want in-order data, I want out-of-order data, I want reliable, unreliable. It's really very cool. But there's one little catch. There's a centralized component in figuring out where your peer is or how to connect to them. So I've got a little diagram that shows you how that works. So these two laptops are your peers, and we have a lot of trouble because of NAT. So we can't just send a packet from one IP to another. So we have to use some sort of cloudy thing to signal where the other peer is. But once we've signaled back and forth, then you can either have a direct data connection, which is this horizontal line, or you can use a relay server and route messages that way. But since it's end-to-end encrypted, you're still getting this very similar effect to just full-on peer-to-peer.
So the only vulnerability in this communication system is you're trusting the server that signals, not humanity.
Yes.
So,
yeah. If you were, I mean, you could always, if you were wanting to connect to a certain peer, maybe you could have the peer sign the, cryptographically sign the signaling information, and that would be one way to mitigate that, but.
Or you could have the peer discovery in the blockchain.
Or in the blockchain too, but then you have to run, there's back and forth, there's a handshake, so if you're going to be waiting like 5 minutes before you connect to someone, so it's going to kind of suck. Of course, you could always bootstrap a network by doing that if you wanted, and then as your first peer, and then use them, and so on.
So right now, if you use it, let's say the browsers, Chrome or whatever, who's the cloud right now?
So that's the thing. Who's the cloud right now? How do you signal? There's not a really easy way. Right now, it's kind of application by application based. So if you kind of have to go to the same website or use the same signaling server. So it's not ideal at all.
I mean, it's amazing that every web browser has the capability for doing end-to-end encrypted video chat, but we don't have that piece.
Yes, not yet. We'll hopefully at some point we'll be able to.
Now say that again. What pieces that we don't have? Oh, you mean the
So we have every web browser ships, every major web browser today, with the exception of Internet Explorer, ships today with the capability for doing end-to-end encrypted video chat, except for how to find the person you're chatting with on the network.
Okay, all right.
How to verify that person is who you think.
Yeah.
So the CA piece.
Yeah, we need some sort of like WebRTC signaling protocol that allows for a secure transfer of your signaling information. I don't know how exactly. I'm working on a little something. We can talk later. So I'm going to go over some examples here again. These are pretty basic. So here's a very basic friend list. So here Ethereum is going to be storing who we are wanting to communicate with. So, basically, if you're, I'm just going to walk through this contract line by line. So if you're not the contract creator, it means you don't own this contract, and it's not going to do anything, so it stops. Otherwise, if there's going to be two commands. If the first data 0 is a 0, it's going to store information. Otherwise, if it's a 1, it's going to suicide the contract. So if it's a 0, basically you're going to store you've got basically a key and a value that you're storing. So it's the key, the index key plus 1000, which is an arbitrary value to get out of this contract code area. So a key plus 1000, and you're setting that key equal to the value, which is your second. Oops, this is a typo here. It should actually say tx.data2 on the right-hand side of the equal sign there. So kind of how that would work is, let's say you have a friend. So you're wanting to store a friend's address in the blockchain, and maybe we figured out a way that you can just with an Ethereum address query some sort of signaling server and initiate a connection. So now you have, and also only receive connections from addresses that are in your address or in your address book. So you can add all of the addresses of your friends who you know that they're trusted because only they have the key, and then you can only accept connections from those addresses that are in this contract. Well, of course, the value there doesn't have to necessarily be an address, or it could also be like a contract address. So maybe you're just linking to your other friends' identity contracts, and maybe there's other sorts of identifiable information that you could use to validate a connection. And realize that's all a little nebulous, but since we don't really know what an identity contract exactly looks like, but we can imagine that maybe there's an IP address in the identity contract, and now you know, based on a lookup from this contract, it'll say, oh, your friend's address is in contract 123. You go look at contract 123, and it tells you he's on IP address whatever, and now you know I can securely accept a connection from that IP, or I guess it's IP spoofing, so you're not going to really be able to. If there's also a public key involved, then you can have everything signed as you're doing it, and validate that that person is who they say they are.
What is TX value 1?
Yeah.
Why is it?
Oh, that's actually also saying sorry tx.data 1.
Oh, okay.
Any questions on this one? Okay, so we're going to go to another example. This was a little bit more convoluted, but all right, let's just go through it. So before we get into the actual code, to kind of explain what this does. So this is a topic group connection list. So basically what it does is you add in your address and an optional identity contract into this contract, and it groups you by topic. So then what you would end up doing is only allowing connections and only initiating connections from within that peer group. And that could be either through the address itself or through some mechanism within the identity contract associated with those peers. So we would add our address to the topic we want to subscribe to. We would query those peers in that list, and then we would do whatever communication we were doing. And so the app logic just needs to make sure and only allow those peers in that list. Okay, so here's the logic. So we've got two different commands. The first command is we're going to be able to update our contract. We're only allowed one contract per address in this contract, and the other command is going to be updating our topic, so which topic we're subscribed to. So if tx.data0 is equal to 0, that means we're updating our contract. If the contract address that we're trying to link to is not valid, then we're not going to allow it. Otherwise, we're going to store our contract address at the key value of our Ethereum address. So basically, if you were wanting to do a lookup through this contract, we can look up a certain address and get a contract address associated with it. So if tx.data0 is a 1, that means we're updating the topic that this Ethereum address is associated with. So if the topic that we're trying to query is less than 1,000, so if it's not valid, then we're going to stop. And if we're going to be storing the topic that we're currently subscribed to in our address +1 in that slot. So if that already exists, that means we have already subscribed to an old topic. So we need to go back through and remove all references to it and add our new topic. So we get the topic root, which is the SHA-3 of the current topic, of the old topic. We get the length of that associated list, and then we get the current index of our spot in that list, which is stored under the sender's address +2 that slot. And then we basically replace our slot in that address list under that old topic with the very last element of that list, and that's just a really easy way of basically pulling our name out of that list, and without having to pull our name out and then scrunch everyone else back up. So we're basically just taking the last guy and putting him in our slot to remove our name from that old topic. And then we decrement the length by 1, and we delete that last address that we had taken out and put in our spot. This was all just to get our old address out of the old topic and kind of make that whole topic area a lot more, or make that topic list correct. And then we basically do a similar thing, except now we're adding our address to the new topic that we are adding our address to the new topic that we're subscribing to. And I guess I'll go into this in a little bit more detail with anyone who wants to afterwards, but yeah, it's dragging on a little. And that's kind of the end of what I had. Yeah.
How do you see the web front end of these things to make them user friendly? Would it be sort of like posting something on on DigitalOcean with like a web page front end to a full node of Ethereum, so the chain's right there? Or is that running it locally or for messaging, let's say?
Yeah, I don't know if it's currently possible right now, but I could see maybe having a light node of Ethereum running in a JavaScript client and just pulling just the piece of the contract or just the contract that you're currently using. Yeah. And then maybe using some sort of WebRTC to actually send the data between people.
I was thinking of something like, Gmail or something where it's all hosted in the cloud, full client on the cloud with a web front end to it. You never see the Ethereum client, just the web app talks to it. And you're just accessing it like any other web app.
Yeah. I'm thinking you could also maybe host your own node and have have it serving a WebSocket and connect in that way.
Doesn't having it hosted on the web kind of destroy some of the security?
That's just
ideally not.
What's that?
Ideally not with WebRTC and being able to host your own node and possibly having a WebSocket or having some sort of way to connect to it securely.
Okay. I was actually, I mean, I think one of the things Andy suggested, I think, was having the full node be on the web.
Yeah,
So that-
yeah, and so the problem with that is, like, what are they really doing with the web form where you're entering the data? You can independently verify what goes on with the chain, but, like, what else are they doing with your stuff, right?
Right.
Yeah, it's an issue.
Okay, great.
Yeah, so maybe like a browser, like a browser extension, kind of get around that. But yeah, if anyone has any, anyone's really interested in WebRTC, I'd love to chat with you and continue.
That's